All right, determining net force. So let's talk about different situations. All right, so here's the first situation where this object is speeding up. Is there a net force? And the answer is yes. If it accelerates, it has a net force. If I look at the dots here on this one, the dots look pretty constant velocity. So is it a net force? And the answer is no. And then I look here, it looks like this object is slowing down ever so slightly, which means it's accelerating. Is there a net force? And the answer is yes. So let's look at graphs. A velocity time graph where we have a constant velocity. It's not accelerating, therefore no net force. But this one and this one both show a negative acceleration and a positive acceleration, but there's an acceleration here and here, which means there is a net force in both of these. So speed up or slow down, net force. Constant velocity, no net force. Okay. Now how to calculate net force. We will look at these three situations on the board. Do it now.
All right, let's look at net force in three different situations. So I have something attached to a rope, so I got tension, I got gravity pulling it down because there's always gravity. My tension force is 1200, my gravity is 800. So what I would do is I would pick up as positive and down as negative, and I'd add them together. So I'd say 1200 minus 800 equals 400. All right, so my net force is 400 newtons. Since it's a positive answer, it's going upward. So it's 400 newtons up. Okay, here I have air resistance up at positive 600, gravity down at negative 800. So now I add these together. I take 600 plus negative 800 gives me negative 200 newtons. So now I look at this, it's 200 newtons is my net force, because I just added all my forces together, but negative means down, so it's 200 newtons down. You can say negative 200 newtons, but negative and positive could change. So if you get a negative answer, that just means you're going down. Now I look here, I got 50 going up, 50 going down. 50 minus 50, because that's positive, and this is negative, equals 0. So there's no net force up and down, but left and right there is. Right's positive, left's negative. So I have this, which is 0, minus 20 equals negative 20 newtons. So my net force is 20 newtons, and negative's left, I say 20 newtons to the left. And again, don't make negative, just say 200 newtons down. But you have to give a direction.
We will look at these four situations and find net force. We will do it now.
All right, so here's our situation. Situation A, we got a box, we got an applied force of 5 newtons, a frictional force of 5 newtons. We have a normal force of 3 newtons and a gravity force of 3 newtons. Remember, up and right are positive, down and left are negative. So I take my vertical and add them together. So I go 3 minus 3. So in the vertical, my net force is 0 newtons. Now I do the horizontal. 5 minus 5, 0 newtons. So no net force in the horizontal either. Okay. Situation B, again, up and to the right, positive, down and to the left are negative. So I do my vertical first. 3 minus 3 is 0 newtons. And then I go here, I go 0 minus 5, negative 5 newtons. So my net force is 5 newtons, negative's left, to the left. All right, let's look at this situation here. Up, down, right, left. This is 0, 0, that's okay, so up and down. I go 20 minus 20, my net force, 0 newtons. Up positive, down negative. So I go 40 minus 25 equals 15. It's a positive number, so it's 15 newtons into the positive direction, which is up. Again, positive and negative give us direction. Don't include those in your answer unless you have to.
Then we will take a different look and we will have the net force, but we will solve for some of the extra forces that are provided. We will do that now.
All right, so the last type of problem will be trying to solve for individual forces known net force. So I look here first, and again, positive, positive, negative, negative. If my net force net is 0, okay, 0, that means all my forces are balanced. So this one doesn't require a whole lot of math, but I know if this is positive 50, to get to 0, A would have to be negative 50, right? And I know that if negative 200, and this is something, has to equal 0, then this also has to be positive 200. So if your net force is 0, the two forces opposing each other are going to be the same number, right? Here, we have 900 newtons up. All right, so we're trying to find C. Remember, this is positive, this is negative. So I make an equation, and I go C minus 200 equals my answer, 900. And now I just solve for 900, or solve for C. So I add 200 to each side. So C is 1100 newtons. So that's 1100 newtons. All right, so now I have multidimensional here. I have left, right, up, and down. Remember, positive, positive, negative, negative. 60 newtons left is my net force. So the first thing I want to look at is here. So this is D is positive, so I go D minus 80, right, equals 60 newtons to the left. So this would be minus 60, right? So I add 80 to each side, and D is equal to 20 newtons. So D is going to be 20 Newton force. Remember, if it's going left, it's got to be negative, so that's why I had negative 60 there. Now, up and down, since it doesn't say there's a net force, I'm going to assume it's 0. So if that's 300, E also 300 newtons. All right, let's look at this one. Last one. F net is equal to 30 newtons to the right. Positive, positive, negative, negative. Let's look at up and down first. Since there's no net force going up and down, this can be whatever I want it to be. So I'm just going to say 50 and 50. As long as they're the same, it doesn't matter. But now here we got G minus 200 equals, and it's going to the right, so it's positive 30. So I add 200 to each side, and G is 230 newtons. So you can, using net force, you can also find individual forces using algebra.